Hi, good day to everyone. I'm Nobel and I'm going to present the topic of ocean carbonic system. So, what is this talking about? The ocean carbonic system is a gas action mechanism of carbon dioxide between the ocean and atmosphere, and it plays a vital role in regulating the pH of seawater and the amount of carbon dioxide in the atmosphere. Besides, the ocean carbonic system involves few core assistant components, which are carbon dioxide CO2, water H2O, carbonate ions CO32-, bicarbonate HCO3-, and carbonic acid H2CO3. Carbon dioxide gas dissolves into the oceans and combines with the water to form carbonic acids. Once CO2 is hydrated, it is involved in a series of proton transfer steps to form bicarbonates and carbonate ions. When seawater is too basic, H2CO3 will dissociate to form HCO3- and H+, resulting in lower pH value. In another way round, when seawater is too acidic, HCO3- will react with H+ to form H2CO3, resulting in raised pH value. Next, I'm going to talk about the carbon exchange. There are three processes involved in carbon exchange, which are photosynthesis, respiration, and decomposition. Photosynthesis is the process by which carbon dioxide reacts with water and light to produce glucose, oxygen, and water. Respiration is the process by which glucose reacts with oxygen to form carbon dioxide, water, and energy. And finally, decomposition is the process by which organic particles are broken down by bacteria and other microorganisms, releasing carbon dioxide and other dissolved inorganic carbon species in the process. That's all from me. Thank you.
Hi, I am Atira. Acid act as a proton donor. A substance that can give another substance a hydrogen ion, while base accept protons, accepting hydrogen ion from another material. The characteristics of acid are sour, feel sticky, react with most metal to form hydrogen gas, and usually gases or liquid in matters. pH is a measurement of the H+ concentration in a liquid. pH scale for acid is less than 7 and change litmus paper blue to red. There are 4 types of basicity of an acid, which are monoprotic, diprotic, triprotic, and polyprotic acid, where mono stands for 1 H+ ion, D for 2 H+ ion, 3 for 3 H+ ion, and poly for more than 3 H+ ion per molecule. Strong acid will ionize 100%. Most of the strong acid are monoprotic acid except for sulfuric acid, diprotic. The characteristic of base are bitter, feel slippery, frequently solid in matter, and react with oils and greases. pH scale for base is more than 7 and base change litmus paper red to blue. There are 4 types of acidity of base, which are monohydroxy, dihydroxy, trihydroxy, and polyhydroxy base, where mono stand for 1 OH-, D for 2 OH-, 3 for 3 OH-, and poly for more than 3 OH- in water. Strong base will ionize 100%. All of the bases of group 1 and 2 metals except beryllium are strong bases. The most familiar salt is stable salt, which is sodium chloride. Salt is ionic compounds that are composed of metallic ions and non-metallic ions. Salt dissociate water. These bonds are weakened and the ions become mobile. This accounts for the fact that salts are generally electrolyzed. Neutralization reaction is the reaction of acid and bases to form salt and water. Hydrolysis reactions are reversible, where reaction of water and salt to form an acid and base. Thank you for watching. Bye-bye.
Ocean acidification is the reduction of pH of seawater for an extended period of time, primarily due to the uptake of carbon dioxide from atmosphere by the ocean. Ocean acidified when the concentration of carbon dioxide in the atmosphere increase due to human activities. Carbon dioxide will be absorbed by the ocean and will react with water to form carbonic acid and hydrogen ion. Free hydrogen ion will bond with carbonate ion to form bicarbonate ion. So the concentration of carbonate ion in the ocean will be decreased. Carbonate ion is required by the marine life to build and maintain calcium-based structure like coral and shell. So when the concentration of carbon dioxide in the atmosphere increase, it will limit the marine life growth in the ocean. Ocean acidification can give a bad impact to the marine life. Firstly, calcifying organism will reduce its ability to produce calcium carbonate in a more acidic water. So certain organism might dissolve its shell in acidic water. It is acidosis, When the concentration of carbonic acid in the body fluid of an organism increase, the pH will become lower. This will lead to metabolic depression and affect physical and reproduction of the organism. A recent research by Dr. Justin Rees from the University of North Carolina states that certain organisms like lobster, crab and shrimp shows a positive response by calcified at higher rate and increase in mass in the lower pH environment. Meanwhile, the same research also states that certain organisms like oyster, scallop and temperate coral shows a negative response toward the pH lowering. Calcification rate decrease and some organisms have a dissolved shell due to pH lowering.
Hi everyone, I'm Yin Chu with metric number S66913. We would like to present about evaporation, precipitation, and freezing. First of all, what is defined by these three natural processes? First, evaporation is the process by which an element or compound transitions from its liquid state to its gaseous state below the temperature at which it boils. Second, precipitation is the deposition of liquid water droplets and ice particles that are formed in the atmosphere and grow to a sufficient size so that they are returned to the Earth's surface by gravitational fetching. Lastly, freezing is a process through which a substance changes from a liquid to a solid when its temperature is lower below its freezing point. This is the water cycle, also known as hydrologic cycle. It describes how water moves on, above and below the Earth's surface. As water moves through the water cycle, it is constantly changing between different states of matter, which are solid ice, liquid water, and gaseous water vapor too. The geographic location of a region plays a significant role in determining the variation of evaporation and precipitation. As the insolation decreases with latitude, temperatures are highest in tropics and decrease towards the poles. However, although the equator has the highest evaporation rate, it is not the location with the highest salinity because rainfall is also high. The highest surface salinity for open oceans is located at about 25 degrees north and south in the center of the subtropical gyres. Variations of precipitation and evaporation create large-scale of salinity patterns throughout the ocean. Where evaporation is higher than precipitation, seawater salinity is higher around 20 degrees to 30 degrees north and south, while vice versa happens around the equator and at higher latitudes. These salinity variations then generate thermohaline currents and thus influence the vertical movement of water in deep oceans. For instance, increased salinity means increased density. The seawater sinks, whereas decreased salinity decreases the density and thus the seawater rises. There are numerous applications of these three processes. First, production of fresh water from seawater, which is so-called a desalination process. Next, salt production evaporated from seawater. And lastly, lower the freezing point by adding salt into water or ice. There is some reference I have reviewed. Bye bye.